Welcome, everyone. Thank you for joining us for OA Week 2023. My name is Yuman, and I'm my OA Week coordinator. Please note that this session is being recorded. OA Week is presented by 4 sponsoring organizations. First, the Global Ocean Acidification Observing Network. Second, the United States National Oceanic and Atmospheric Administration. Third, the International Atomic Energy Agency, Ocean Acidification International Coordination Center. And last but not least, the Intergovernmental Oceanographic Commission of the United Nations, Educational, Scientific, and Cultural Organization. GOA-ON was established in 2012 with just a handful of members. Since then, GOA-ON has grown immensely. It now has over 1,000 members from 114 countries. GOA-ON also consists of 9 regional hubs, which span across continents and oceanographic regions. We will be hearing from most of them throughout OA Week. If you are not a member yet, you can join GOA-ON today by visiting goon.org. OA Week debuted in 2020 and returned in 2021 when events and conferences were postponed due to COVID-19. Following the successful in-person symposium on the ocean in a high CO2 world in 2022, GOA-ON is bringing back OA Week 2023 to maintain momentum around OA research and provide a virtual platform for the ocean acidification community to exchange their latest findings. We are thrilled to present a wide range of ocean acidification topics and speakers from around the world. During the presentations, all participants are in listen-only mode. You are welcome to type any questions into the questions box, which can be found at the bottom of the control panel on the right-hand side of your screen. We will be monitoring incoming questions and will pose them to our speakers during the question and answer session, which will begin immediately after the final presentation. For the discussion, you can also use the raise hand function in the toolbox at the bottom of your screen, and we will call on you to ask your question directly. With this, I would like to introduce you to your moderator for this session, Dr. Currie. She is a scientist with an IWA in New Zealand. As part of the Ocean Atmosphere Interactions Group, she is responsible for surface ocean carbon programs, including the Moonidai Time Series, a long-running transect of ocean carbon measurement off the coast of New Zealand. She is a part of a multidisciplinary team working on ocean acidification in New Zealand and has initiated a coastal ocean acidification observing network, where she works with a variety of stakeholders and collaborators to improve understanding of ocean acidification conditions and consequences for New Zealand coastal ecosystems, communities, and businesses. Kim serves as International Ocean Carbon Coordination Program co-chair and is on the Global Ocean Acidification Observing Network Executive Council. So Kim, the floor is yours now.
Thank you, Yuming. Kia ora, everyone, and welcome to this webinar, another in the series of OA Week. Yuming, can you put up my slides, please? So this session, everyone, is around the OARS working group for outcome number 1. So OARS is the United Nations Decade Ocean Acidification Program, Ocean Acidification Research for Sustainability. And it consists of, next slide, please, consists of 7 outcomes, next, of which working group 1 is around enabling the scientific community to provide ocean acidification data and evidence of known quality. Enabling the global scientific community to provide adequate ocean acidification data and data synthesis products to allow determination of the progress and trends of ocean acidification through the world's coasts and oceans requires that scientists and stakeholders have the resources and the capacity to make sustained observations of known quality and to integrate these data into national, regional, and global synthesis products. Next slide, please. So we've divided within this outcome number 1 into 5 main groups, which we're calling pillars. Next, the first pillar is the sustained and integrated physical, chemical, and biological observations. So that's the actual getting out there and making the measurements. Next, the second pillar is the value chain of ocean inorganic carbon measurements. So that's taking the measurements through the data management, quality control, data archiving, data combination, and then data products. Next, the third pillar is taking those data and producing data synthesis products which are tailored to the end users. Next, the fourth pillar is around capacity building and mentoring, ensuring that all of those who are wishing to contribute to data observations and the full value chain have the ability to do that, both through knowledge, through expertise, and through equipment and resources. Next, the final pillar is around communication and collaboration building. Next. So today's webinar, we've taken each of those pillars and asked one of our champions to present on an aspect of that. So we've got a wide range of people contributing on a wide range of subjects which are pertinent to ocean observing. So without further ado, I'd like to introduce our first speaker, Dr. Richard Feely. So Dr. Feely is a NOAA Senior Fellow at the NOAA Pacific Marine Environmental Laboratory in Seattle, Washington in the US. He also holds an affiliate full professor faculty position at the University of Washington School of Oceanography. His major research areas are carbon cycling in the oceans and ocean acidification processes. Dick received a BA in chemistry from the University of St. Thomas in St. Paul, Minnesota in 1969. He then went on to Texas A&M University, where he received both an MS degree in 1971 and a PhD degree in 1974. Both of his postgraduate degrees were in chemical oceanography. So Dick's presentation is going to address the first of those pillars, pillar number 1, sustained and integrated physical, chemical, and biological observations. So over to you, Dick.
Well, thank you very much for that nice introduction, Kim. I really appreciate that. What I want to focus my talk today on is the GOA-ON network and the data products that we envision that are available now or could be available in the future if the community wants to do so. So I'm going to give you a series of examples of a walkthrough through the various data portals and the kinds of information you can download from them. Within GOA-ON, we, through the governance documents, we've developed 2 types of measurements that are available. The first is the climate quality measurements. These are data that have sufficient quality to assess the long-term trends and is defined a level of confidence. So we know exactly what the quality of the measurements are, and each measurement data point has that indication of what the confidence is through the metadata processes. And that allows us to determine the long-term changes. 2 examples of that are the SOCAT data set that Dorothea will be talking about and the GOSHAP data sets. We also have the weather quality measurements. These are measurements that are of sufficient quality to develop spatial and temporal variations and spatial patterns, and to get a mechanistic understanding of the responses of individual organisms or ecosystem to the changes that we are seeing. And this is demonstrated through the GOA-ON data portal, as well as the Sustainable Development Goal portal. And I'll show you examples of each of those in a minute. Now, through the GOA-ON data portal, they have both the Explorer application for looking and exploring all the data sets that exist, as well as the Sustainable Development Goal portal, which I'll show in a minute. And the Sustainable Development Goal portal is the newest of the data portals, supporting a lot of the observations from laboratories that do not have data centers within their own countries. Now, this is the basic map that you would get at from the GOA-ON website. And it's a listing here of all the different kinds of observations throughout the world. And if you click on any given point or line or station, you will get an ability to inquire into those data sets, actually get at the data set itself, get the metadata and the PI information in order to really get a handle on what the data is that is available, is temporal variability and spatial variability. And it comes from a series of fixed time series stations throughout the region, supported by ships, also moorings, other platforms, time series stations, in some cases, the BGC Argo floats, drifting buoys, repeat hydrographic sections, and also volunteering observing ships. The data sets, when you click on them, will also provide you links to the metadata and also give you an indication of the data provider. And when you click on those, you have the ability then to see what kinds of data are available at these locations, and therefore click on those and get an indication of the data set itself. And in addition to that, at the data portal, there is some capabilities to present the graphic representations of the data itself. Here's an example, for example, in the global fugacity of seawater based on the observations alone. And you can see you can click on various kinds of measurement parameters and you get a very good indication of what those variability is in that region. Now, in addition to that, you go to the GOA-ON data portal, you can also get access to the SDG 14.3.1 data portal. And then from there, you can get into some of the data sets that are uniquely uploaded through that data portal. And right now, it's been going for about 3 or 4 years now. And we have seen that every year it's growing. 539 stations in 2022 from 41 different countries have reported in through this data portal, and also has applications for analyzing the data sets itself, and you can see the distribution of the individual parameters over time and space, and you can also get some indications of the overall variability. So there is a very good set of tools available through this portal to help analyze the data sets. Now, for SOCAT and GLODAP, this is a portal focused primarily on the climate quality data sets dating back to the 1960s or so. And this is a good representation from a paper that was just released this past Monday. The cyan colors represent the SOCAT stations for each of the decades from 1961 to 1990 through 2011 to 2020. And the red values are the GLODAP and CODAP data sets. And so you can see there's very good distribution of data sets between each of different decades, and you can then get access through these two data sets. Now, through the SOCONET and the GLODEP data processing, there is a series of procedures that go on to help provide data products. The data sets are brought into SOCONET, and then they're combined with surface measurements of mixed layer depth, sea surface temperatures, chlorophyll, and they're utilized then with a series of algorithms to get at things like PCO2 and other parameters. This is an example of that. They're combined with satellite data to give global maps. And usually the maps that are represented are on a monthly basis. And you can also extend it further with wind products to get at fluxes. And this is how we provide the observational data for the synthesis analysis through the IPCC process. I show this map in particular because you can see that we can get at very useful information about the monthly changes from year to year, and you can conceive of how we would then use the same surface PCO2 measurements combined with alkalinity measurements to get at things like pH or aragonite saturation. So we have the ability to extend from what it is now into the future to get very detailed information on the distribution of all the ocean acidification parameters that we normally work with. This is an example of the kinds of data sets that we gather from the time series. This is from Adrian Sutton's work, again published in Oceanography magazine this week. And here's an example of time series data dating back from 2006 to 2020 for a variety of different stations in the open ocean on the left-hand side and coastal waters on the right-hand side. And by utilizing these time series, we can start making comparisons from one location to another and to see indications of whether or not the slope is the same, whether or not it is different, and get some indications of how the trends are changing over time. In some instances that we have seen the Western Pacific, for example, the slope actually changes over time as well as oceanographic processes either enhance the acidification rate or decrease it. This is an example of some of the decadal analysis that has been done with these data sets. From this example here, again published this past week, we have looked at for the first time the decadal changes in hydrogen ion concentrations on the left and pH on the right. And you can see from these means for each of these time segments, very significant changes over time with a buildup of the hydrogen ion concentration and a corresponding decrease in pH. And so from these kinds of data, we can see what the regional differences are over time in this global perspective. And we can do this now for all the carbonate parameters and looking at aragonite saturation or calcite saturation or PCO2 or total CO2, and get a really good sense of how the oceanographic conditions are changing in your area. And the thing to note from that, of course, is that there are significant regional differences. Some places the rate is very fast in the change, in other places the rate is much slower. And from maps like this, we can discern how these changes are taking place. This is from the work published by Zhang et al. In 2023, is a time series map of the hydrogen ion concentration over time based on combination of observations and model. And Liqing Zhang has shown us that we can utilize the models then to make very accurate predictions under different CO2 emission scenarios and utilize that information and now to show what changes would take place on different scenario types. And this is very valuable information, particularly for policymakers when they can see what changes would take place under low and high CO2 scenarios. Another way to look at our data sets is as we develop these carbonate parameter data sets and work with our biological colleagues to develop the relationships between the carbonate parameters and the biological responses, to when we can feed the sensitivities that are associated with these chemical changes that are taking place into the GCM models to develop predictions of what the biological changes would be like at present and in the future. And this is the first representation of that with Nina Benarsik working with Nikki Gruber's group to establish the biological changes in terms of pteropod dissolution for the global oceans. And this is based on the chemical data embedded into the model with an output of the biological response. And not surprising, we see very large biological responses in the high latitudes in the Northern Ocean and in the Southern Ocean, but also in the upwelling regions along our coasts and in the upwelling regions in the tropical Pacific. And this is something we probably did not expect. And so the models are giving us an indication of where to look in terms of biological changes in the future on the kinds of timescales that are useful to our policymakers. And as we can see here, is that we might look to the tropical regions in the Atlantic and the Pacific to see biological impacts that we have yet to see. In addition to our work with the present day observing system, we're also developing new technologies, and new technologies will have to be integrated into the observing network. Examples of that are the CO2 sensors that are on surface autonomous floats like sail drone, or in the subsurface waters, carbon measurement parameters for BGC Argo floats that profile from the surface down to 2,000 meters. These are new data sets that are coming online very shortly. Will provide enormous amounts of new data and will provide us with the opportunities to get more detailed information, either where ships can't go in case of sail drone, or to get profiles at high resolution in the water column that we haven't been able to do before. So there are new technologies that are coming along. We'll have to integrate these new technologies within the data systems that we have and incorporate those data sets. Other things that we're doing within the outcome one is to evaluate the capacity of the observing system. They do this with outcomes 3 and 4. We ensure adequate traceable certified reference materials are provided. This is an ongoing effort as a collaboration between Scripps Institution of Oceanography and NIST. We're developing standard operating methodologies for all the laboratories and developing best practices, particularly for new technologies. And we're improving in situ carbonate measurements technologies all the time, and again, in collaboration with Outcome 3. So we have a very intensive effort going on, and we're welcoming more members to join our group. And with that, I'll end the conversation with these primary conclusions that we are quickly moving into an area of increased density of global carbon measurements via existing and new technologies. The challenge is, how do we increase the throughput of measurements while still providing high quality outputs and data products? And can the scientists reach consensus on new data services and data products that can be made available to the entire community? So I would looking forward to the conversation at the end of this session, and looking forward to hear your ideas on these topics. Thank you very much.
Thank you, Dick, for that incredibly wide-ranging and deep and up-to-date as well, with papers that were just published earlier this week, but giving a fantastic overview of the state of the play at the moment, and also some questions to ponder as we go forward, and increasing the number of observations and how we deal with those. So I see that, Maribel, you've got your hand up, but it'd be better, I think, for us if we could leave your question till the end, if that's okay. So I'll call upon you after our last speaker for your question. So now I'd like to move on to our second speaker, who is Dr. Dorothy Bakker. She's an assistant professor in marine biogeochemistry in the School of Environmental Sciences at the University of East Anglia in Norwich in the UK. She studies the marine carbon cycle from estuaries through to shelf seas to the southern and Arctic oceans and multidisciplinary seagoing projects. Her research interests include an ocean uptake of carbon dioxide, processes driving variation in this uptake, progression of ocean acidification, and land to ocean carbon transfer. Projects include Mosaic, Piccolo, Green Feedback, and the Rathera Antarctic Time Series. So Dorothy is chair of the Surface Ocean CO2 Atlas, that's SOCAT, a high-profile synthesis activity by marine scientists worldwide. So Dorothy, thank you very much for participating in this. Dorothy will address pillar number 2, which is the value chain of ocean inorganic carbon measurements. Dorothy, over to you.
So thank you, Kim, for this introduction, and I hope you can all see my screen. Well, let me know if you don't. So yes, I'd like to speak about the value chain of ocean inorganic carbon measurements. And for this, I'd like to use examples from the Surface Ocean CO2 Atlas, SOCAT, and also from GOA-ON.
Sorry to interrupt, we're unable to see your screen at the moment.
Right, I'll better try something else. And can you see it?
Yes, we can see your directory.
Yes, you don't want that.
No. Interesting, though.
It's not very interesting. Can you see it now?
Nope.
And now?
Yes.
Good. Well, I'll leave it like that then.
Okay.
Sorry about that. I'd like to speak about the value chain of ocean inorganic carbon measurements, and I'll illustrate this for SOCAT and GOA-ON. And specifically, I'd like to thank Britt Alexander and Jerry Chiputra, who have helped improve and design the figure of the value chain that is on one of the following slides. I'd like to thank Masao Ishii because he told me that this kind of thing is called a value chain. And I'd like to thank all the contributors to SOCAT and GOA-ON. And some of the key contributors are listed here, but there are many more of those that are not listed here. So this figure shows the value chain of ocean inorganic carbon measurements. And we published this figure in a report by the European Marine Board on big data and marine science. And then the figure here is kind of amended a little bit from that original figure. So this value chain is key for the quantification of global ocean uptake of carbon dioxide, its variation, and its response to net zero. And it's also key for quantification of the progression of ocean acidification. So the value chain at its lowest level has the observations that are carried out on research ships, on ships of opportunity, on moorings, on autonomous platforms. Recently also measurements are being made on sailing yachts. And in case of measurements in the interior ocean, those are either by profiling autonomous vehicles or they are by water samplers such as the CTD. And some of these measurements are part of observing systems, and 2 examples are shown here, but there are more. So that's, for example, ICOS, the Integrated Carbon Observation System, and SOCONET. And then what is a very important step is, first of all, that these data that are collected are quality controlled by the data providers, and then that these data are submitted, first of all, to data centers, but if where it's possible, also to relevant synthesis products. So SOCAT and GOA-ON are synthesis products for ocean inorganic carbon measurements. I'll show a bit more in particular about SOCAT in the next few slides. But when we put these synthesis products together, we carry out additional expert quality control. And if the data are deemed of good quality, then we make them public, either once a year or every 2 years or something like that. And these synthesis products are then used for all kinds of scientific studies. And these may include mapping the distribution of CO2 in the surface ocean. And also Dick in the previous talk showed a number of products where data from SOCAT and GOA-ON have been mapped. The synthesis products can also be used for data assimilation, for modeling, and also for forecasting with models how the future ocean might look like. And then colleagues around the world use the results from these studies for writing scientific papers. And these results then feed into scientific assessments, such as the IPCC reports, and also some of the estimates of ocean CO2 uptake are used by the Global Carbon Budget in their annual budget. And this then feeds into high-level climate negotiations by the United Nations Framework Convention on Climate Change. And if all is well, then there also is a feedback mechanisms by a variety of international organizations back to the colleagues around the world that are collecting the data, and also, if necessary, to, for example, the synthesis products and the modeling. This value chain is very important because the data collected as part of this value chain have shown that the oceans take up about 1/4 of the CO2 emissions from human activity. And also the measurements here by colleagues near and at Hawaii show the increase in CO2 in the atmosphere, and then also how this results in an increase in CO2 in the surface oceans and in a decrease in surface ocean pH. So, for example, this study shows the importance of, first of all, making very accurate measurements, making them over a very long time, and then in putting these measurements together. So in SOCAT and in GOA-ON, we carry out a synthesis of ocean inorganic carbon measurements, and we carry out expert quality control. These are very much community efforts, and over the past 15 years, we have had a number of meetings where we discussed how to carry out this quality control and what criteria to use. And I'm very happy that next week we will have a series of surface ocean PCO2 workshops in Oostende, Belgium. And this is a hybrid meeting. And if you're interested, then go to that website and you can still sign up for online attendance only by contacting Tobias Steinhoff, one of the lead organizers. So in SOCAT version 2023, we published this version in mid-June. So you can find links to everything via our website. And in SOCAT, we have a synthesis of in situ surface ocean CO2 measurements. We have an annual public release. Currently, we have 36 million CO2 values with an accuracy of better than 5 microatmosphere. And these data originate or were collected between 1957 and 2022. And of course, most of the data are relatively recent. These data are made public in our main synthesis products and also in our gridded products. And then in addition to that, we also have 7 million CO2 sensor data with a slightly lower accuracy. Now we are working with the SDG 14.3.1 data portal that Dick also mentioned in the previous talk to have a smooth transition and make the data that are available in SOCAT also available to the data portal. And one of the things we are doing for this is that we are automating the metadata upload to SOCAT so that it will be easier to share our metadata with, for example, this data portal. This figure on the top right shows the data distribution in our gridded product. So it shows the number of monthly grid cells with a CO2 value over different years. And what you can see is that the max number of data was maximum in 2016 and 17. And we're actually very concerned about this apparent decrease in the number of observations from 2018 onwards. And this decrease was then exacerbated or made worse by the COVID pandemic. And in this figure, you don't draw too many conclusions on the last bar, because we always have less data in the final year than in the years before that. But we're concerned about this apparent reduction in surface ocean CO2 observations. Then this figure on the bottom right shows the number of observations in SOCAT for 4 years, so from 2018 to 2021. And there are some regions with quite a lot of data, so that's where the colors are maybe yellow or greenish. In other parts of the world, we have maybe 4 months of data per year, so that's where the colors are blue. But also there are very large parts of the oceans which are colored white, and that means that no data were collected in that period between 2018 and 2021. At least they were not submitted to SOCAT. In my view, the value chain is at risk. There is, in my view, an alarming decline in the open ocean CO2 measurements. SOCAT itself, so this synthesis product, has lost one of its regional hubs in 2022. And at the moment, we're just hanging on there. We're trying very much to continue. But also SOCAT struggles with chronic funding shortfalls. And we really, at some stage, need to upgrade our IT systems to more modern software. And as Toste Tanua, one of the co-chairs of GOOS, observed a few years ago, only 20 to 25% of the ocean observing system is sustained, so has long-term funding. And the rest of it is funded by research. Now, I wanted to show that these measurements that we collect and put together in SOCAT are really important, because you can see in the sea green color, so those are the lines on the top, you can see estimates of ocean carbon uptake that are based on data products derived from SOCAT. And then the purple lines, which are lower in the figure, they show estimates of ocean carbon uptake from 10 ocean biogeochemical models. So the Global Carbon Project or budget reports the ocean CO2 uptake as the mean of these two the thick lines. So it reports the ocean CO2 uptake as the mean of the estimates based on the data and the estimates based on the model. However, it's important that there is a 0.8 petagram of carbon per year gap between the mean of the models and the mean of the data products. And here the models indicate a lower ocean CO2 uptake than the data products. So this is a key knowledge gap. And now that we have this key knowledge gap, it's really important to understand where this difference comes from. And the only way to do that will be to collect, to have a good data distribution for the oceans. So in my view, we should stabilize the value chain of ocean inorganic carbon measurements. There is a need for sustained high quality in situ ocean inorganic carbon observations and their synthesis. Adequately sampled, carefully quality controlled and archived data for key elements of the climate system will be useful indefinitely, as stated by Carl Wunsch in a PNAS article. And then that same article, Carl Wunsch also said, and colleagues also said, that any measurements that are not taken today cannot be made in the future. So any measurement, if we're not doing good measurements today, then we'll never know what the CO2 system was at that particular location in the ocean. Another statement, in this case by Richard Sanders, is that if we consider the value chain, then this value chain is as strong as its weakest link. So, below are some of our suggestions on how to address this, at least as far as SOCAT is concerned. So we should end the decline in surface ocean CO2 measurements, and that's particularly for the open ocean. We would very much appreciate emergency support for SOCAT so that we can produce versions 2024 and 2025. And in the longer term, and this is in the context of the WMO's Global Greenhouse Gas Watch Initiative, we should transition to an operational surface ocean CO2 observing capacity that can deliver monthly air-sea CO2 fluxes at the 1 degree by 1 degree resolution. So to conclude, we should stabilize the value chain of ocean inorganic carbon measurements. And if there are problems with surface ocean CO2, then these might well be much more widespread. This value chain, and not just for surface ocean CO2, but also for other key variables, provides key knowledge and addresses key knowledge gaps. Thank you.
Thank you very much, Dorothy, for that really great overview of the current status of the value chain for inorganic carbon, but also a fairly, I guess, blunt warning about the risks that it's facing and the consequences of that, and also look forward to the discussions further on this next week at that meeting in Austin, which you also advertised during your talk. So thank you very much for that. If anyone has questions for Dorothy, remember you can put them in the chat box, or at the end can raise your hand during the question time. So I'd like to move on now to our third speaker, Nico Lange, who's presently a postdoc at NORSE in Norway, working on the Global Ocean Data Analysis project version 3, that's GLODAP. So Nico recently finished his PhD at DMR in Germany. Congratulations on that, Nico. And his PhD focused on marine biogeochemical data synthesis products and included realizing GLODAP version 2 annual updates. And he led the pilot of SPOTS, which he's going to talk about today. Nico is a steering committee member of the Marine Ecological Time Series Research Coordination Network, the METS-RCN, and is also a member of the IOCCP, the International Ocean Carbon Coordination Project. And he's the member responsible for synthesis activities. So today, Nico is going to address pillar number 3 of OARS outcome 1, which is production of data synthesis products tailored to end users. So Nico, over to you.
Yeah, thanks, Kim, for this nice introduction. I hope you can see my screen now. So yeah, I'm quite glad that the 2 previous talks have already introduced you and highlighted the importance of data synthesis products, especially when it comes to the provision of high quality ocean acidification data. So that in my talk here, as Kim just mentioned, I can focus a bit more on the technical aspects and in particular on the production of data synthesis products tailored to end users. And I will do that mainly by means of presenting the development of the synthesis product for Ocean Time Series, in short, SPOTS. And for SPOTS, just this summer, we have actually been able to release a first pilot product for it. And as you can see on the left and right hand side, also here a lot of international partners actually contributed to this pilot product. And eventually we were able to include data from 12 ship-based fixed time series stations from around the globe, which you can see here in the map. And before going into any further detail here though, I first also quickly, again, rather from a technical standpoint, elaborate a bit more on the purpose of synthesis products within the ocean observing system. So as the way the system is set up, it provides and generates a lot of individual data sets, which the amount is great. Many data, the more data, the better. However, these individual data sets are also quite heterogenic, and they are quite scattered and fragmented around different national oceanic data centers or other data access portals, for example, the SCG 14.3.1 data portal. So that for scientists, it actually already becomes quite a huge challenge to find all the data that is out there. And this is exactly where synthesis products kind of step in and organize these data around specific scientific rationales. So we've heard now about SOCAT, for example, that here the clear goal is to provide high quality data to determine sea surface CO2 fluxes, for example. And more generally speaking, these synthesis products usually focus on either a particular variable or a particular ocean observing platform, or sometimes actually they do both of it. But the point here is, by doing so, they make data mining already a lot easier. However, it is very important to understand that these synthesis efforts do not just simply collect all the data and organize them around these themes and then just throw out all the products, but they also tackle the data challenges linked to the especially heterogeneity of the data. So they not only collect the data, but they harmonize the data, for example, also they do formatting, and as Dorothy has also mentioned before, they put on an extra level of quality control on top of the already applied internal quality control. And it is this high level quality control applied by the synthesis products which differentiates these also strongly from other data management efforts. And exactly here, it's also where the methods become more tailored towards the different targeted end users, but also towards the different data sources, so towards different data observing platforms. And also something synthesis efforts kind of always strive towards is to make the data more fair. And I hope that fair, this is a term that you've heard before. Just in case here, quick sketch. So the synthesis efforts try to make the individual data sets more findable, more accessible, more interoperable, and more reusable. And so here it's very important also to understand that metadata plays a key role in that. And this is then eventually how the synthesis products provide coherent and consistent data that ideally also have achieved that the individual included data sets become comparable and that a high quality can be ensured, as you've heard for the accuracy numbers examples for SOCAT from Dorothy for SOCAT. And yeah, you've seen this. This is actually now the old version, I guess. You've seen this data value chain before, so I don't want to go into much detail here. The only thing I want to highlight is that for in situ inorganic carbon measurements, before spots, the two relevant products were SOCAT and GLODAP. And the thing is, neither one of these products actually includes fixed point time series data. Hence, these data, at least when we look at this data value chain pyramid here, kind of fall a bit through the cracks, and their impact on the high level services are limited. And that is despite, as also Dick has impressively shown with some examples, despite the uniqueness and benefits that come from these observations. Also, when we, for example, look at the space frequency domain, you can clearly see how they have a unique position in that domain compared to all the other observing platforms. When you look at the lower left and compare the orange and oh, there's an echo. Okay, hope it's better now. Okay. So the orange and the black circle when you compare it to the other colored circles. And also, when we consider how many data is actually out there, we really see that there is a need for a more organized way instead of just all the data time series stations providing the data individually. When you look at the lower right map and see all the, just looking at the ship-based time series stations at these blue dots. So pretty much that was the call for spots. And spots then needed to tackle the data challenges linked to time series data. So again, that was first of all the implementation of, or at least increasing the fairness of time series data. Here we have to think first of all about metadata, meaning that not only general higher level metadata is important, but also metadata that makes it able to differentiate between different applied methodologies is present. So that in itself was a huge undertaking. And also not only obtaining this data, these metadata, but also enhance them and make them interoperable. And here we worked with the Ocean Data Information System catalog together so that we can distribute these information now through machines and make them more interoperable. The same is true when we look at the different time series stations and what kind of ontologies and semantics they use. So they have different names for the same variable or same names for different variables actually. And to kind of disentangle that, semantic mapping was needed. And also when we think about distributing eventually the data, automated services such as ERDAP become important. So these were the challenges linked to fairness of the individual time series data. And the other big point, which we tried to improve through the pilot, was to enhance the inter- and interstation comparability of all included time series stations. And herefore, I cannot highlight this enough. It is very important to have a consensus within the community how to achieve that and where the limitations for the different methods are actually at. And eventually, leveraging from the knowledge of GLODAP and from the knowledge of SOCAT and their applied quality controls, within the pilot, we decided to provide 4 types of indicators, which we think increase the inter- and interstation comparability of the included stations. And the 4 indicators are listed here on the right-hand side. So precision and accuracy estimates, interconsistency estimates. So these interconsistency estimates actually try to link consistency to the variability at a certain depth of a particular time series station and a particular variable. Then also how far the data compares to the GLODAP data product, for example, can give further insight into the quality as well as to the comparability of individual data sets. And last but not least, we applied an in-depth method assessment. And that method assessment, I will also show you on the next slide, a quick example. That was, first of all, based upon rich metadata, so linked to the fairness of the data too. And it was based upon defining a set of method recommendations within the time series community on how actually the different variables should be measured. And these recommendations were then further split up into required and desired recommendations. And for each data point, this is then the result is now shown here, the method how to obtain this data was then evaluated against our recommendations. With in dark green showing the data points for each time series station, now for the example of nitrate, that fulfill all our recommendations. In light green, only fulfill the required recommendations, and in yellow, the data which do not meet our recommendations. Obviously, the granularity of this assessment is not unlimited. So we had to, at a certain point, stop with our recommendations, so to speak. Hence, not all changes of methods could be incorporated into our assessment. And these non-incorporated changes are highlighted here by these black lines. And what we try in combination with the other indicators, what we try to achieve here was that for each of the included stations, we can now see in how far the different methods might or have a high chance of being comparable to one another. So dark green indicating that most likely the data that has come out of for these years are very comparable within one time series station and across the different time series stations. And by just providing such data to the end user, we simply increase the utility of time series data. And when you look, for example, at trend analysis, etc., you can go back here and link maybe some changes to artificial impacts or to actual natural variability or anthropogenic driven changes. So with the pilot where we have focused on ship-based time series data and focused on biogeochemical essential ocean variables only, we were able to apply our assessments, to apply our quality control checks, and to make the data fair for 12 time series stations from around the globe, which you can see here, amongst others also the station from Hawaii, the Aloha station being included, which was also shown before on a slide from Dorothy. And all in all, these 12 different stations actually cover quite a variety of time series programs with different temporal resolutions included, different time ranges included, and different bottom depths included. And we even have some rather coastal stations included, so not only open ocean stations. And the pilot itself now has more than 100,000 water records included. And if you look at the oldest one, it's from 1983, and the newest one, which is from 2021, we also cover already quite a wide range in the time. Hopefully, of course, this pilot will now be the foundation for a more sustained and long-living data synthesis product for time series stations, where we include more stations, where we can think about including more and other variables, as well as in the long term, even moorings. So extending the impact of the synthesis product. And just to come back to this data value chain, so maybe now it has to be updated one more time. We can also now include spots in here, and hopefully now time series stations and their data will have a greater impact on this assessment as well. And that is also my last slide. So thanks. Stop sharing screen.
Thanks a lot, Nico. Thanks for describing the need for such a time series product is what you've pulled together. I know it's been a big job shepherding all of those who are involved. And nice to see that there's now an extra entrant on that second level of the value chain pyramid. So I'd like to move now to our fourth speaker, Dr. Caitlin Lauder from the Ocean Foundation. Caitlin supports the Ocean Science Equity Initiative at the Ocean Foundation and works to increase ocean science research capacity around the globe, with a particular focus on training tools and low-cost technology. In her capacity as a program manager, she leads international workshops for scientists, delivers low-cost sets of equipment to initialize ocean monitoring programs, and supports the development of resources and materials to enable high-quality methodology that's to be accessible to lesser resourced research groups. So Caitlin, ideal to address pillar number 4 of OARS Outcome 1, which is around capacity building and mentoring. So Caitlin, the floor is yours.
Thank you so much, Kim. I am really glad to be here talking about Pillar 4, which is focused on capacity building and mentoring to grow our community and enhance its sustainability. So for this outcome, it's really focused on that equipping the global science community part of our outcome goal. And as you can see from the talks during our webinar today, we've benefited from a great working group for this outcome, but I've been particularly fortunate to work with this on Kim, it's based at NIWA, and I'm based at the Ocean Foundation in the US. All right, so we all know that it's necessary to observe, manage, and mitigate oceanification on scales from the local side to the regional to global, from the coastal ocean to the open ocean, and from the surface to the deep waters. But equitable access to oceanification observing allows regions to manage their own coastal environments, as well as contribute to the global integrated system. But many regions don't fully have this local expertise, the infrastructure, and the resources fully built out that are required to implement an oceanification observing program. So capacity building is a really vital component of achieving the Outcome 1 goal, that our whole community is equipped to produce those data. And to do this, we have some existing efforts to draw upon and ensure across the globe we're able to do science together and link that to those follow-on products that we've heard about earlier. So I'll share a few examples of these current approaches, but we should also be looking forward across the whole decade and beyond to ensure that for our international community, we advance together as our field develops on things like data management, metadata management, use of reference materials, etc. So to grow the amount of quality data all around the ocean's coast, researchers need to be able to have the tools to collect the data and to do that well. So there are a number of existing resources for researchers who are just entering our field to support their ability to collect and share oceanification data, including low-cost technologies, online and accessible guides, mentorship by more experienced researchers, and online and in-person training. So I'm going to go through each of these in a little bit more detail in the next few slides. And what I'm sharing is just a few examples, certainly not a comprehensive list, but maybe with the help of those of you online, one day we can have that full list of everything that we're all doing to help support new researchers in producing those good data. So the first example is that of low-cost accessible technology and equipment to support monitoring called the GOA-ON in a Box kit. This includes everything but electricity in the seawater to allow for opportunities for institutions, academia, ministries, organizations to produce carbonate chemistry data. So what you see here on the screen are just a few examples of the items that are in the kit. There's actually over 90 unique pieces, and you can find the full spreadsheet that I maintain on the GOA-ON website with those instructions there. And by the end of 2024, we anticipate 27 kits will have been distributed to 21 countries to enable weather quality observations in regions where previously data were sparse or non-existent. But funding for these has come piecemeal through separate projects, which doesn't allow for the long-term vision of providing these kits that can be used around the globe and actually fill in some of these coastal regions where there are sparse amounts of data. So sustainable funding for that model is really necessary in a vision for this decade. And this is just one example of low-cost ways to collect data. We heard in the sensor session earlier this week about tools like the FIDER that enable even more researchers to obtain environmental carbonate chemistry parameters. And we believe that the continued development, testing, and distribution of low-cost instruments is required to take advantage of advances in sensor technology and use them within our field. And with new low-cost sensors, we can imagine that there'll be great expansions of temporal and spatial resolutions for data that can allow researchers to characterize their environment, answer their own research questions, and then contribute to some of these global data products that are so important. And so to support those tools, clear and standardized methodology really helps. Dedicated SOPs for the GOA-ON in a Box kit are being developed. They're closely aligned with those of the wider observing community. For example, using reference materials while measuring bottle samples to allow the integration of those data if appropriate quality control measures are followed as they're trained. But for other researchers who use other sets of equipment in the OA community, there are other resources out there as well. I really love the ones that Remarco has. They have some great guides and videos online. And then for all of us in the community, the IOC has tons of resources for submitting data to SDG 14.3.1, including some templates, a nice FAQ webpage, and previous webinars that walk through the process in depth. Also, the 2 guide to best practices are, in my opinion, oldies, but really goodies. They're great technical references that we can continue to introduce to new researchers to enable them to build up their body of knowledge and enter the field. And then on the training front, this is an example of an online resource. The IOC's Ocean Teacher Global Academy is a comprehensive internet-based training platform. An OA course has been developed for it, which has 7 great modules currently, including 2 that I'd like to bring particular attention to. Module 3 on data quality and management, which is led by Adrian Sutton, and then Module 4 in SDG 14.3.1, put together by Katerina and Kirsten. So last year, the Ocean Foundation led an online training for those in the Pacific Islands to use this course. And when we surveyed respondents or the attendees, we heard some really great feedback. And so I'd like to highlight one from an attendee who said that I learned many new things, most importantly, understanding oceanification, a better understanding of the SDG 14.3.1 and data quality management. So I think it's really neat to hear that across all this information that person learned, they really appreciated the data aspects and learning what to do with the data that they collect. But other training material has been developed by a variety of institutions in our community. Here at 2F, we lead trainings for new recipients of the GOA-ON in a Box kit. The OA ICC supports trainings with a great breadth of topics in person as well. So a directory of those training material resources could be developed, maintained, and extended as new resources become available. And also mentoring is a really effective part of capacity building, where experts can provide tailored assistance to individual or small group trainees. There's several existing mentoring programs that work on oceanification, including projects within POGO, and of course, the GOA-ON peer-to-peer program. Peer-to-peer has matched dozens of mentor and mentee pairs within the OA community over the last couple of years. This provides really great insight for these pairs to advance their oceanification knowledge or even extend the learning from previous hands-on trainings that the mentees have received. And in some instances, applicants have used the peer-to-peer scholarship to hone in on data analysis in preparation for submission and publication. So that mentorship pair and the support for that allows them to overcome that final hurdle and get the data into a shareable, publishable format, which is really great to see when those applications come in. And then for those who are doing more advanced work in the oceanification community, those who have more established labs, there are still opportunities to learn and refine our approaches throughout the rest of the ocean decade and beyond. We know there are many ongoing changes to expand the production, the distribution, the use of reference materials and secondary standards for that analytical quality control that will affect all of our work. And so we will probably need associated training or guidance for that to ensure the ongoing provision of known quality data. And of course, the uptake of standardized metadata, like harmonizing our vocabularies and ensuring we have the correct metadata to help ensure data meet FAIR principles. Thanks, Nico, for the call out and the explanation of those. That can require training, templates, and other resources too that can benefit our entire community. And so in total, we have the potential need for resources and upskilling to assist regions to utilize the relevant data in their data products to manage their own coastal environments. But those should also be part of the global system too, and meet that duality between the local, the regional needs and the global products as well. So alrighty, that brings us to some ideas of what we can all work on together throughout the ocean decade. Firstly, I think it'd be beneficial for a community to find ways to strengthen the sustainability of key capacity building programs, like supporting new research teams through equipment, training, and research support. That's, I think, a tall order unless Bill Gates is online, probably not, but it's something we can think of how to do to provide support for new researchers who are just getting their footing in the field. And then also through mentoring as well. The peer-to-peer mentorship program is incredible, but we are thinking of novel ways to pair a large group of mentees who are just entering the field and more experienced mentors as well. And for anyone online, you don't necessarily have to have been working in our field for decades, right? As long as you have some expertise that you're willing to share with others, I highly recommend you sign up as a mentor for the program. It's a really rewarding experience. And then together we can co-develop resources for a full synthesis of all that we have on training materials so far, bringing together all the information on workshops, whether it's basic training or to those specialized workshops like what Nico was sharing for the SPOTS tool next year. Bring that all together so we can hear about what the needs are and really build off what we've all put effort into. And so we can think proactively about coming together to standardize our approaches and continue advancing new methodologies. There's also, opportunities to continue to advance the way that we're using some of these materials through the OTGA course, specializing that for certain regions that have particular needs, honing in on getting great data out of those particular areas. And then because that low-cost equipment is so important for expanding the ability for researchers to conduct OA research in many regions of the world, of course, talking with those developers and explaining the importance to our entire field. But I hope in our discussion session today, we can also chat about what all of you online would like to do for the decade, how you can contribute to OARS, to this outcome, and especially this pillar. So with that, I touched on a number of topics that our community has been working on. We'll be speaking in more depth in other sessions this week. One is our best practices session tomorrow, which has a few touches on capacity building, but also some great talks on advancing the process and outputs from spec pH measurements. There is a talk tomorrow as well focused on regional capacity building. Very excited for all of these great examples of what's going on around the globe and how we're advancing the community in that way. And then finally on Friday, what is sure to be a great session for peer-to-peer, highlighting some work that some researchers, some mentees have been doing with the support of scholarships. So with that, I'll end. And as a reminder, this is a great number of authors that have worked on this. So I'm happy to answer questions and pass along feedback to our working group as well. Thank you.
Caitlin, thank you very much for that. A really good reminder of the need to involve as many people as possible in as many countries and many regions as possible in order for us to fulfill our goal really documenting the status of the world's ocean with respect and coasts with respect to ocean acidification, and allow countries to manage their own resource as well as contributing to the global whole. And yeah, you highlighted the different some of the different resources and programs that are going in to help achieve that, and good to have the challenge of what more needs to be done within the decade. Thank you for that presentation, and also the shout out for the other couple of relevant sessions later in the week. So our fifth and final speaker for this webinar is Jessie Turner, who's the Executive Director of the International Alliance to Combat Ocean Acidification, the OA Alliance. The OA Alliance is a voluntary initiative of national and subnational governments. The Alliance works to raise ambition for climate action and transform the global response to climate ocean change. As Executive Director, Jessie sets the strategic direction of the Ocean Acidification Alliance and develops and carries out annual programming, including contributions to international convenings. She also establishes partnerships across a variety of disciplines and coalitions, develops communication strategies across multiple scales, and supports members in the development of practical ocean acidification adaptation resilience strategies. So today, Jessie's going to take that background and talk about ways to address our pillar number 5, which is on communication and collaboration building. So Jessie, take it away.
Well, thank you so much, Kim, and everybody for having me in this session. It's great to be part of this group. And I will say I'm not part of OARS Outcome 1. I am indeed part of OARS Outcome 2. And following along today, I think this talk, I'll try to get through it so that we have time for conversation. I might skip some parts, but it's maybe non-traditional in the sense of thinking about synthesis products, but I would suggest that, we've been thinking a lot through the OA Alliance and through OARS Outcome 2 about how we engage different stakeholder groups, policymakers around the need for synthesis products, communications products, policy guidance, and how these things are very distinct, but they're also very interdependent. And so my talk is kind of weaving out of those things, and hopefully there'll be some useful information relayed from me to you about OARS Outcome 2 and how we're thinking about the OA information for decision-making. And of course, I've been asked to speak about the need for OA data to inform the wider stakeholder community. And so my first big takeaways from that are things that we've already heard today. We need to be able to communicate and engage and talking about filling regional gaps. That's an equity issue and has financing needs associated with it. We've heard today, obviously, about continuity, value chain, time series. We want to be sharing the impacts of climate change and carbon emissions on ocean and coastal resources. And increasingly, we want to be informing discrete actions and decision-making. So one thing I just want to share a little bit that we've been thinking about is advancing the narrative. This is a slide from Dr. Carol Currie back in 2019, looking at ocean acidification searches on Google. We can see that in 2003, we had 17 hits, but in May of 2019, nearly 8 million. And I think one thing that tells us is that awareness of ocean acidification is growing. And as that interest and awareness grows, we need to be thinking about communicating or synthesizing information and data for different audiences and discrete outcomes. And really for us, what that has meant is moving from describing what is OA and why does OA matter to what can different actors do to address OA. And of course, the answer to that really depends on the scale of information and the different outcomes that we're looking to manage for, including just reducing CO2 as an urgent need globally and locally. So to put another way, this is really thinking about raising awareness versus behavior change, or really highlighting what can OA information help to deliver. And one thing that we've been doing through the Alliance, I think many or some of you are familiar with the Alliance, we're working to engage governments, both national, subnational, tribal, First Nation, municipalities, ports, on coming together and helping them understand what they can be doing, what they need to be supporting by way of investments in some of the science near shore, and some of the monitoring near shore to help them actually take action on ocean acidification. And when we have conversations with governments about this, the big questions that often come up when we were talking about OA policy and management, it's really what can be done now versus later, which actors are responsible for specific activities, and will action help accomplish existing goals, policies, or targets that already exist around climate, marine management, sustainable development, etc. And so we all know here that OA is a multi-sectoral issue. Obviously, we're talking about climate mitigation and adaptation, risk assessments and preparedness, ocean and land management, food security, coastal and community resilience, aquaculture, blue carbon, water quality. And this is sort of the prism by which we're starting to think about how OA data and evidence is seen through these different lenses, is what I'd say. And one thing that we do, of course, is trying to paint the entire picture so that it's not just ocean observing or open ocean observing to track pH trends, although that is important. We are thinking about combining that with ongoing projections of warming, oxygen loss, what these combined impacts are having on our resources, and what those ecosystem services, how those impact ecosystem services that humans are depending upon. Of course, this is all things that we're doing when we're thinking about communicating and what type of data is needed to communicate these different topics. So one thing that the UN Decade of Ocean Science and OARS Outcome 2 has been working on, so that is to identify data and evidence needs for OA mitigation and adaptation at different scales. Which of course is a big job and very much tied to outcome 1 when we are thinking about what type of quality and quantity of data we're looking for what purposes. And so how do we do that? That's a big question. And we're working through it is the answer. So one thing that we've really set ourselves up with was some guiding questions. The first being, what are decision makers actually charged with managing or regulating? What can policymakers or marine resource users actually do with information at different scales? How much data? What is the quality of data needed to support different objectives, right? Very much getting into the set of presentations that we heard from today. And some of the first things that we're looking to do, of course, is to wrestle a little bit with this conversation about what can be done with the information we have versus what actions or decisions will require more discrete data. And we do that by really soliciting active engagement with policy, management leaders, marine users around their information needs at different scales. And so we're really trying to make this a two-way conversation. But we often find through the Alliance that a lot of times policymakers, marine resource users, they don't know the answer to those questions. They don't know what can be done with OA information at different scales. And so that's really the job of some of this communication, is to engage stakeholders to help them be more prepared to give us parameters that they can use and synthesis that they can use. So into the future, I'll quickly say that we want to continue to support a process in 2024 and beyond that helps outline stakeholder needs, develop new tools, whether that's synthesis, communications, policy guidance, really continuing to translate science application to accelerate uptake and utilization of this information, which of course requires a co-design process for streamlining and mapping how we can do that together. So here's just a quick example of what we put together originally. This is a little bit of a brainstorm to simply say, how would we break this apart to think about different scales? So at first we were sort of thinking about like global and regional scales. What kind of decision-making relevance could you use with global scale information? What information is available possible? What does it tell you? Instrumentation and tools required, timescale needs, readiness factor, and what policies or support implementation or acceleration of that work. For time, I'm not going to read all the way through, but you can get the sense here for the global scale information, really talking about supporting messaging on climate ocean change, impact, risk assessment impacts, mitigation and adaptation needs across international frameworks. A lot of what Dr. Feely was suggesting about the high-low scenarios, very important. Helping make sure that that information is really getting taken up and understood across the UNFCCC, UNSDG, and reporting through same. Then we get into regional scale information that looks a little bit more granular, and national information that looks a little bit more granular, looking at predictions for reef conditions or fishery stocks assessment, carbon sequestration potential of different marine ecosystems. How does OA information inform targeted regulations or closures, things like MPAs or marine spatial planning, or inform other terrestrial activities that might have relationship to water quality conditions. And then at the local level, really digging into things like discrete hatchery practices or discrete fisheries management in place-based locations. Again, with terrestrial activities, linkages to local pollution, terrestrial pollution, water quality, and how localized OA information can support community-based adaptation and resilience. And so this has not been released yet. I will just quickly show it here. We are working on a product with OARS that just sort of puts that in a little bit more clear buckets. On the left-hand side, we say decision-making category for policymakers. How can OA information help to inform that larger decision-making category? And this will be just sort of one highlight to then link more into the OARS website, check out all of the work that we're working on to make sure that we are answering these questions. How can OA information help with these different activities? I'll just read them quickly on the left. The 6 buckets that OARS 2 is focusing on is documenting change and informing climate ocean risk. Number 2, assessing food security and resilience of seafood economies. Number 3, assessing best applications of marine management tools. Number 4, assessing carbon sequestration potential of marine and coastal habitats. The 5th, exploring local remediation and adaptation strategies through reduction of land-based pollutions. And finally, how can OA information help assess the potential risks, benefits, monitoring needs related to marine carbon dioxide removal strategies? So that's just a little teaser of what we'll be working on to finalize. But we still need tools and synthesis products in addition for just communication. What can local governments do to address ocean and coastal acidification? What do policymakers need to know about ocean acidification? These are super high level communications documents. They're not the type of synthesis products that you guys are speaking about, but they're related, of course, because the synthesis products that you guys are creating need to be able to be plugged into these type of broader questions that policymakers are entering this conversation from. And then last, I'll stop for time so we can have a little question and answer. There's just one, just basic. How do you measure ocean acidification? I think most people, most policymakers, most people that are not in our practitioner community, present company included, this is useful information. And so this is just a quick little mock-up of, what 4 parameters are we talking about when we're measuring for ocean acidification, just to give a little bit more shared terminology in a glossary. So I'll pause there. I had a little case study for UNFCCC relevance, but I'll pause and turn it over for questions so we can have a little bit of time for that. So thanks, Kim, for inviting me, and hopefully that wasn't terribly off the mark.
Thanks a lot, Jessie. That was fantastic. And I think it's a really good reminder to us in working in outcome number 1 around collecting the data and then sort of working it up and putting it through to our science products, really what the next step is and how those data and those data products are then used by the work that you're doing and working group number 2, outcome 2, and then through to the other outcomes as well, really recognizing that, making an observation, deploying a sensor or collecting a water sample is the beginning of a great big journey, really, of how that information is used. And I think of that in New Zealand term, we have a whakapapa, which is kind of like the genealogy normally of people, but I think you can think of it as a genealogy of numbers too, what happens to as it goes through its lifetime. So thank you. I think this has been a really fantastic session. We get a little bit pushed for time. There's been quite a few questions in the chat, so thank you for those, and people have answered them as we've gone along, so thank you also to the panelists who've been keeping an eye on that and done that. So we've just got a very few minutes. If anyone's got some questions they'd like to ask in person, so if you want to do that, if you can raise your hand, I'll be able to call upon you. But in the meantime, I was wondering if any of the panelists have any reflections on what's been talked about today. Trying to see the raise the hand thing, sorry. Can't see any hands raised. So what I'm going to do is, given that we're 4 minutes to the hour, I'm going to close off the session and ask you men to finish up for us. I'd like to say thank you very much to everyone, to our speakers, addressing the aspects of our OARS outcome number 1, and to all of you for listening.
Thank you very much, King, and thank you for all our speakers. So at the end of the session, we would like to thank again the organizers, moderators, and the speakers for a great session. And we thank you, the audience, for joining us for OA Week 2023. Please do not forget to consult the website and to register for any other sessions that may interest you. If you would like to stay up to date with the GOA-ON community, consider signing up as a GOA-ON member on our website. To discover more about the ocean acidification research for sustainability, please scan this QR code. Thank you all and see you next time.